Next lesson, titled Trigonometry. Still working with right triangles, but now instead of looking at special right triangles, we're going to look at triangles with any degree measure. So no longer just 30, 60, 90 or 45, 45, 90. We could know a combination of an angle and a side, and we could figure out another side, or we can know two sides and then figure out the angle. All right, so here are your ratios. So something called the sine, or the sine of an angle, equals the side opposite that angle over the hypotenuse. The cosine is the adjacent side over the hypotenuse, and then the tangent of that angle is the opposite over the adjacent. So it might seem like a lot to memorize. I'll show you guys a shortcut for how to memorize this in just a bit, but first let's talk about what I mean by opposite and adjacent and the hypotenuse for the sides. So if I'm looking at angle A, which is right here, the side opposite angle A is side A. The side adjacent or bordering angle A is side B. And then the hypotenuse is across from your 90-degree angle. That's side C. All right, so just don't confuse adjacent and hypotenuse. The hypotenuse will border your angle, but we're not going to refer to that as the adjacent side. That's going to be referred to as the hypotenuse. So we're going to use these ratios. We'll be using the calculator a lot for this lesson to find missing sides and then eventually to find missing angles. So here's our little abbreviation that can help us remember the different trig ratios. So SOHCAHTOA. So if you can remember SOHCAHTOA, that helps you remember that sine is opposite over hypotenuse, right? The O and the H stand for that. That cosine is adjacent over hypotenuse, and that tangent is opposite over adjacent. All right, so we'll practice this. You'll get the hang of it. It won't be too scary once we've done a bunch of problems. So what are the sine, cosine, and tangent ratios for angle T? What I would suggest, guys, focus on angle T and let's just identify our sides first. So GR, which is 8, that's our opposite side. Our hypotenuse is across from our right angle, which is 17 is our hypotenuse. And then our adjacent side is TR, 15. All right, you guys can look back at SOHCAHTOA up there. So the sine is opposite over hypotenuse. I'm going to look at my opposite side and then hypotenuse. So I'll write 8 over 17. All right, the cosine is adjacent over hypotenuse. So that is 15 over 17. And then my tangent is opposite over adjacent, which is 8 over 15. All right, so just writing the ratios for now. I'll have you guys practice, pause the video, and practice same idea, but now we're dealing with angle G. So I'll erase this for you. So this is our angle of focus. Write the sine, cosine, and tangent of that angle. So make sure you correctly labeled based on angle G, your opposite side, adjacent side, and a hypotenuse. And then here are your sine, cosine, and tangent ratios. So I'll rewrite SOHCAHTOA. All right, you have opposite over hypotenuse, 15 over 17. Adjacent over hypotenuse, 8 over 17. And then opposite over adjacent, 15 over 8. All right, some more practice. So the sine of A, if we look at A, where that's located, remember the SO in SOHCAHTOA, so opposite is 8, hypotenuse is 10. And we can simplify that to 4 over 5. The tangent of A, still focusing on this angle, is opposite, so that's the TOA part of SOHCAHTOA, opposite over adjacent, and you can simplify that to 4 over 3. And then the cosine of B, so I'll erase that. Looking at B now, the cosine is that ka of SOHCAHTOA, adjacent over hypotenuse, which simplifies to 4 over 5. All right, so some different types of problems. I'll do A and B, and then have you guys do C and D on your own. So let's figure out what each side is. So the first thing is I'm just going to circle or highlight the angle that's given to me. So I have 54, and I'm going to label my sides. All right, so that's what I suggest until you really get the hang of it. Label your sides always. So X is opposite angle 54, and 17 is our hypotenuse. I'll rewrite SOHCAHTOA. So which is going to use opposite and hypotenuse, the O and the H. That's where sine's going to come in. All right, so you're kind of working a little bit differently. Instead of finding the sine, we're kind of figuring out which is going to be helpful, sine, cosine, or tangent. So I'll now write the sine of 54 degrees equals our opposite side, which is x, over our hypotenuse, which is 17. So now you'll go to your calculator. Make sure when you use your calculator, check the mode. You'll see an option for either degrees or radians. Make sure it's in degrees. All right, so once it's in degrees, you can take the sine instead of 54, press enter, get 0.80901 or 8.8090, I'll say. And then keep that stored in your calculator. All you need to do to isolate x is to multiply by 17 on both sides. That cancels the 17 on the right side, and then you'll get your answer. I'll go back to the calculator. So times 17. We get, if we round to our nearest degree, 14 or 13.8. So let's say 14. Oh wait, nearest 10, 13.8. Oh wait, sorry, not degrees, 13.8 units. All right, let's try B. So the same thing, I'll highlight my angle. Let's identify our sides. 10 is opposite. X is adjacent. So which has that O and A? That's going to be tangent. So the tangent of 28 equals opposite over adjacent. And this is a little bit more tricky because we have x in the denominator. So actually, before I even go to my calculator, I'm going to multiply by x on both sides. So let's get x out of the denominator. And then I have x times the tangent of 28 equals 10. And then I'm going to divide by the tangent of 28. It's getting a little messy, but you guys can follow. So x is going to equal instead 10 divided by the tangent of 28. I'll go to my calculator. 10 divided by the tangent of 28. You get 18.8. All right, so you guys try C and D. set it up. Well, first label, then set it up, then use your calculator. Here are your answers for C and D. So hopefully you recognized you have your hypotenuse and your adjacent side. So you want to use cosine. So the cosine of 33 degrees equals your adjacent side over your hypotenuse. You multiply by your hypotenuse to get that out of your denominator. When you enter that into your calculator, you should get approximately 3.8. And then for D, you actually had more than one option. So you could do one or the other. If you chose to focus it on the 28 degrees, you would do sine of 28 equals opposite over hypotenuse. If you did cosine of 62, you would do adjacent over hypotenuse. This is a good way to check. You should get the same answer in both, which is 106.5, rounding to your nearest tenth. All right, part D, word problem. So a section in Filbert Street in San Francisco rises at an angle of 117, just 17 degrees. So I'll draw that, label that 17 degrees. If you walk up 150 feet up this section, what will be your vertical rise? So we have a right triangle here. We know an angle and we know our hypotenuse. So we're trying to figure out our vertical rise. Call that x. All right. So in regards to the 17 degrees, that is opposite. And we know our hypotenuse. Remembering SOHCAHTOA, which has the O and the H sign. So I'll find the sine of 17. That equals opposite over hypotenuse. We can plug that into our calculator. Just do my separate calculator, save time. Sine of 17 times 105. So as round to your nearest foot. That is approximately 31 feet. So you guys try this problem. I'll read it and explain it. So 1990, the Leaning Tower of Pisa was closed to the public due to safety concerns. The tower reopened after a 10-year project to reduce its tilt. Lots of extra information. Engineers' efforts were successful and resulted in a tilt of 5 degrees reduced from 5.5. So we can see the result here. Someone drops an object from the tower at a height of 150 feet. How far from the base of the tower will the object land? Round to the nearest foot. So we're trying to figure out, use a different color here, this distance here. All right, so you guys try this, set it up, or label, set it up, then solve, plug into your calculator. So here's your solution. You have your, kind of hard because you have your adjacent side and your hypotenuse look very similar. So make sure you're looking at the location of your right angle. So that 150 feet is your adjacent side and you're trying to find the opposite side. So you want to use tangent. So the tangent of 5 degrees equals x over 150. Get rid of that 150 in your denominator, multiply on both sides, and you get approximately 13 feet. All right, different type of problem. So now, instead of solving for a side, we're trying to solve for an angle. All right, very similar process though. So we're going to start by just labeling. So we're trying to find angle x. Let's label the 6 and 10. So 6 in relation to x is opposite, and 10 is our hypotenuse. I'll rewrite SOHCAHTOA. So we have the O and the H, so we can use sine to find our degree. So the sine of some unknown angle, x, equals our opposite side over our hypotenuse. All right. So to isolate x here, we need to do something called inverse sine. On your calculator, it's going to look like you're raising it to the -1 power, but it just means you're undoing sine. All right, so you're going to, what I'll do to show that is just, I'm taking the inverse sine of both sides. So on your calculator, it's going to look like sine -1. You'll put in 6/10. Right. So I'll show you guys on this. You'll typically, your calculator's probably not going to look like this, but if you press second, where you guys, it's hard for me to write on here, but you guys can see that on the top left, second. And then if you press sine, that'll show you that -1 sign. That just means inverse sine. I'll press 6 divided by 10. Enter 36.9 degrees. All right, make sure your calculator is in degrees. All right, and that looks reasonable, I'd say, for that angle. Let's do one more. So we're trying to find x again. So the sine of x, let's label this side is adjacent, and this side is our hypotenuse. So we want to use cosine this time. Sorry, I should not have written sine. I'll just cross that out. So make sure you label your sides. We're going to use cosine. So the cosine here of x equals adjacent over hypotenuse. You will take the inverse cosine of both sides to isolate x. So it'll look like that in your calculator. I will do that in my own calculator here. Actually, I'll do it on the screen. So second cosine 15/20. You could also do 3/4. I'll give you the same thing. So we get 41.4 degrees. And actually, for the nearest degree, we could say 37. Some following directions, and then 41. All right, last problems. Pause the video, try 3A and B, and then check your work. For part A, we're trying to find the measure of angle Y. So I just recognize I have 100 for my opposite side, 41 for the adjacent side. So that's telling me I'm going to use tangent, that TOA part of SOHCAHTOA. So the tangent of Y equals opposite over adjacent. When I take the inverse tangent, plug that into my calculator, I get approximately 68 degrees. And then for part B, suppose you know the lengths of all three sides of a right triangle. Doesn't matter which trig ratio you use to find the measure of any of the three angles explained. So no, as long as you use the correct side combination in relation to the corresponding angle, it won't matter. As I showed you guys before, with this problem, where was it? This one here, right? I could use sine or cosine to find a side. Same idea with the angle. As long as I'm using the correct combination in relation to that angle, you should get the same answer.